In episode 1, we built a green LED heartbeat using millis, so the firmware stays responsive. Today we add interaction, a push button and a second LED red. This is the plant automation station. We are designing a controlled environment for plants starting from simple electronics. The goal is steady, reliable automation that supports healthy growth. We are adding two things, a push button and a red LED with a resistor. The red LED is wired like the green one, GPIO to LED anode, then LED cathode through a 220 ohm resistor to ground. The button is different. One side goes to GPIO 18, the other side goes straight to ground. No external resistor on the button. We will enable the ESP32 internal pull-up resistor in software. In the button control module, we define the new pins. GPIO 18 for the button and GPIO 25 for the red LED. Next, we add a setup and initialization function. It sets the red LED as output and the button as input pull-up. Button inputs cannot be left floating. A floating pin can randomly read high or low due to noise. We fix that by giving the pin a default state using a pull resistor. With input pull-up, the ESP32 enables a weak internal resistor from the input pin to 3.3 volts. So when the button is not pressed, the pin is pulled high. When you press the button, you connect the pin to ground, so it reads low. That means the logic is inverted. Pressed equals low, released equals high. Now we implement the button handle. If the read is low, the button is pressed, so we turn the red LED on. Otherwise, the button is released, so we turn the red LED off. In setup, we initialize both blink and button modules. Before flashing the ESP32, compile once. It catches missing, includes and mismatched functions names early. Now, upload the firmware to the board, then watch both LEDs. The green LED should keep blinking at the same rhythm as episode 1, and the red LED should turn on only when the button is pressed. When you press the button, you may see flicker or multiple transitions. That is button bounce. The contacts physically vibrate for a few milliseconds before settling. Even while the button bounces, the green heartbeat keeps perfect timing. This is the main win of the millis pattern. Input handling does not freeze timing tasks. Next episode, Debounce. We will clean the input signal and make presses deterministic. Thanks for following along with episode 2 of the Plant Station series. If you are interested in more content like this, consider subscribing to our channel or following us on social media.